So what we're looking at here is using OpenStreetMap vector data in Maply. Now Maply is the 2D version of WhirlyGlobe, which is a 3D globe display toolkit. So Maply is a 2D map display toolkit. It's basically all the same technology. Now in this case we're using OpenStreetMap vector data. So it's vectors that are tiled up into chunks in the spherical Mercator that we're paging from the US OpenStreetMap server. And this is work that Mike Migursky has done to try and kind of help standardize on vectors that you can kind of get over the network. So in the lower levels of detail here, what he's done is to provide natural earth data. So we've got land use data, we've got water data, and that's coming from natural earth. As we zoom in, then we start to get the real OpenStreetMap data. Now this map that we're looking at here, this is all vectors. So the water's vectors, the land use data's vectors, obviously the place names and the roads and rivers and things like that. Those are vectors as well. So this is kind of the end goal for something like Maply, is to display an entirely vector map. And here we are. So let's take a look at this area. We're in Florida, so obviously we've got a lot of intricate water. And one of the improvements I made to the recent version of the WhirlyGlobe-Maply toolkit is to deal with the complex aerial features a lot better. So I'm tessellating these on the fly better, and it's coming out much nicer. So the road network's obviously getting a lot more dense. As we zoom in, we're also getting more detailed buildings. This building area here is not very complex, so let's see if we can find something a little more interesting. Yeah, there we go. And you can see that we've even got different versions of the buildings depending on what level of detail we're looking at. Now in this particular example, the place names tend to dominate. I think if you were to do this for real, if you were to put this in a real app, you'd need to make some cartographic choices about what appears where. I'm just displaying absolutely everything at its proper level of detail. But you'd probably want to display some place names but not others, icons for some of the places, change the fonts on the streets, and do all sorts of other things. But mostly what I'm trying to do here is just sort of show off the technology to show that it actually works, so I'm not too concerned with those sorts of decisions. Okay, let's wait for this to catch up, and I'll explain why it does take a while to page in. So again, we're paging this data over the network, but that's not actually what's taken the most time. It's the format that the data is coming in. The server's sending it to us as GeoJSON, which is a nice flexible text format, but it's really slow to parse on the iPad. And I'm running directly off an iPad. This is actually recorded from the iPad screen over the network onto a Mac, and then it's being written to a video file. So it's really running on the hardware. And parsing that GeoJSON for each individual tile ends up taking the most time. So again, if you were to do this in a real app, you might consider doing something slightly different. You might cache the data in a binary format. You might set up your own server. It's hard to say. For areas that are fairly sparse, it actually works pretty well. If we go to a really dense area, let's find a big city, then you'll see that it really tends to dominate. That parsing tends to dominate. Well, you'll have to trust me on that. You won't actually be able to see it. So let's see if we can find Chicago or nearby suburbs, and we'll let that page in. Now in this case, we've got a lot of land use data. We see we've got a lot of those gray polygons, which are different types of land use. We've got some water, but not as much as in Florida, obviously. And then we've got a lot of buildings, as you'd expect in a city. And again, the buildings have multiple different representations depending on the level of detail. And as we zoom in, we'll get a higher level of detail there. And again, what's taking most of the time here is just the parsing of the GeoJSON. So that's something that's perhaps fixable. Or depending on your application, this might be just fine. You might just have a small number of tiles that you store locally. Here we go. Now that's some buildings. Wait for that to catch up. Now what I'm trying to show here are a couple of things. First of all, I really like the OpenStreetMap vectors in tiles. That's really helpful for doing this sort of application, and there's all sorts of interesting things you can do with that. So I'd love to see that become more standard, perhaps even official. It would be great to be able to get vector tiles as an option instead of just image tiles, but I understand there's technology behind that. And what I'm also showing off is Maply, which is my open source 2D map display toolkit. And you can see that it's quite capable. It can display this much data we're getting about 20 or 30 frames a second, and that actually could be improved. And I don't think we're a threat here to the big players. Obviously, Apple and Google are doing a better job of it in their own databases and their own display toolkits. But this is open source, and you can do lots of different things with it that you can't do with those toolkits. And I think it's actually kind of in the same realm as theirs. It's definitely within the within shooting distance of that, and it can only get better. So again, OpenStreetMap vector data in the WhirlyGlobe-Maply toolkit, and all of that is open source. So if you have an application that needs it, give it a try.